Hello, everyone. I hope you enjoyed this conference this day. There was already one talk about the CI/CD, right? And the point here for this talk is a little bit different. First of all, we will take care about what CI/CD really is, because this is something very important. And I see on the market that the understanding of it is a little bit, let's say, not satisfactory. And then we will talk how to deploy, well, Python, because we are on Python conference, Python script, Python Lambda function into AWS using AWS only, right? So the first thing which is very important for us is to understand that having tool like Jenkins, having tool like anything else doesn't mean that you have CI/CD, right? We have a tool only. This is just the tool. CI/CD is more like a process, like a approach, like a procedure. The best description here is process. How we deliver our code, well, to clients, right? So, my name is Pawel Piwosz. I've been working for EPAM Systems right now for 3 years as a lead system engineer. And most importantly, I am a DevOps Institute ambassador, AWS community builder, and recently I become a CD Foundation ambassador. So one of my focus is AWS, obviously AWS community builder, and second, CI/CD, what is obvious as well here. And DevOps is, I'd like to say that my nature. Right? So what is CI/CD? The problem here is that we have CI, which is understood differently. We have CD, we have different CD. So generally speaking, we have two CDs, right? And now this creates some kind of problem, some kind of tension event, and we don't understand really what these three elements mean. So let's figure it out. Finally, this from the beginning to the end. So what we have in CI/CD, we have, as I said, three elements. We have continuous integration, CI. We have continuous delivery or continuous deployment, CD. These two CDs, right? So what is continuous integration? It's simple where it starts, right? It's collaboration. It's regular committing of your work. But it's also about unit testing and all other, there's like a first front testing, right? This is about different scans, security scans. This is about compliance scans. This is about the code quality scans. This is about code coverage scans, right? And CI ends in very specific moment of the lifetime, right? It ends when we build the artifact and we store this artifact somewhere. This is the closing element for CI. And from this moment, we can start talking about CD. And on the beginning, CD is very similar for both of them, continuous delivery and continuous deployment. So what we can say about continuous delivery, this is about automated testing of different environments. This is about the automated delivery of this artifact created in the previous step into these environments. But also we need to remember that we need to control what we deliver and how we deliver it. And the most important element of continuous delivery in, let's say, this prism of continuous delivery and continuous deployment is that continuous delivery is not fully automated from the beginning to the end. Continuous delivery has some moment where manual intervention, whatever it means, right? It may be just someone who click, okay, go on, or even the whole committee for the release or release management, change management, etc. Right? And I'm calling this one-click deployment. The difference here between continuous delivery and deployment is here. continuous deployment means that we deliver our artifact to all environments automatically with production. So production is included here. So after the commit, we can go home and everything should be delivered to the production as automated process, right? And I'm calling this zero-click deployment because there is no intervention, completely no intervention. So let's visualize this again, just to be sure that you got my point. First, we have a commit, right? After the commit, we do some kind of static code analysis, right? For the application code, it may be done with SonarQube, for example. For the infrastructure as code, because here we can also do this static code analysis. We can use different tools like Chekhov, like Terascan, etc., 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 to control the quality of our template. After that, we can execute unit tests. And here you can think, why in the pipeline, right? Because I should do unit tests maximum in the pull request, or even before I even commit to the repository. Yes, that's true. But this is what you can do, right? Or we as a developers. Here in the pipeline, we want to have unit tests in order to measure the progress, measure the quality, measure the code globally, let's say, through our project, right? That's why we have this unit tests here. We build the artifact. We can test this artifact. What we can do here, for example, imagine the situation that the build artifact is about container. We can build this container and test this container even locally in terms of pipeline, and be sure that this container is built properly, right? We can do security scans for this container here as well. And then on the end, we store this artifact somewhere. It can be whatever. It can be some registry for containers. It can be like npm storage or pip storage. You can name it, right? So even simple S3, because we're talking about AWS, even simple S3 can be a storage where you store, where you keep your artifacts. And this is CI. CI ends on this moment. In this case, after this moment, we can start another pipeline. Even sometimes we use two pipelines. Sometimes this is one pipeline only, but another part of this process, CD. In this case, we start with collecting artifact, obviously, which we built previously. We can deploy it to QA, for example, as an environment, do some tests, deploy to release candidate, do some tests, etc., etc. Then we have manual approval. And after that, we deploy to production. And this is continuous deliver. When we remove this step, we have continuous deployment. Looks very similar, looks very simple, but logically, what is done for the automation for continuous deployment is definitely more complicated than for delivery, because we need to be sure that what we deploy on production really works, right? So what we will do or watch today, we'll do a very simple thing. So we'll do this very simple thing because I am DevOps in very complicated way, right? So this is what is already deployed because it takes some time to deploy. So I already deployed this. So we will deploy Lambda function, or we will use Lambda function, which is behind API gateway, and user can execute this Lambda using triggering endpoint in API gateway. Simple like that, right? So this is created with the full CI/CD pipeline, which use AWS CodePipeline, because AWS tooling. We will use full richness of this, almost full richness of CodePipeline. the only one thing which I already have and I do not change with the CloudFormation is the repository itself, which is in code commit. The deployment will be done using CloudFormation, and the pipeline will be created using CloudFormation. So now, few words about the tooling which we are using here, Lambda functions especially, right? What is Lambda function? It is a way of serverless compute or delivery serverless compute power to the customer by AWS, right? So AWS serverless service is called Lambda, and here we can run multiple runtimes, including Python, of course, in multiple versions. Generally, there is always slight delay between the when the new version of Python or any other runtime is announced by let's say producers. AWS need time to improve their platform and add this runtime to the platform. So there is a chance that some version of Python which is already deployed, already available, is not ready yet in the Lambda function, right? So you have multiple options like Python, like Node.js, like Golang, like .NET, Java. And also you can, if you wish, for example, to have Lambda function as a Docker container, or Docker container as a Lambda function, I should say, it is possible as well. Honestly speaking, I see only one reason to use this approach. When you have already a containerized application and you want to use serverless. But please remember that Docker here is kind of wrapper, which is run on Lambda function, which is kind of wrapper for virtual machine, which is micro VM, which is run on some hardware. So the number of layers, this virtual layers is quite huge, and you can feel it. But for example, you can have bash script as a Lambda function. It is possible. You can use custom runtimes. With AWS Lambda, there is one element which you need to remember. With Python, it is visible as well. It is visible on all serverless platforms, because serverless doesn't mean that there is nothing behind it. Obviously, there is a server somewhere, but this server is not managed by us in any way. It's not visible for us in any way. That's why serverless. And when we trigger for the first time our Lambda function, or we trigger this Lambda function when we didn't trigger it for the longer time, generally 15 minutes, we are hitting something what is called cold start. This is the moment, the time which is needed for AWS to provision this micro VM, to provision all packages on it, to install all packages, to create the whole infrastructure around it in order to allow you to execute your functionality. And this cold start may be very significant in time, because when you imagine that you build a website, and normally your website is responding for the request in 200 milliseconds. And cold start is adding you additional 2 seconds. It is quite impactful, right? That's why, for example, those of you who know knows a Cloud Guru, if you know what to look for, you can see very clearly this cold start, because a Cloud Guru is built completely on Lambda, on Lambdas from the beginning, really. So you need to remember about this, especially when we have synchronous invocations, when we work with web pages and things like that, right? So enough about Lambda. Another element which we will use is AWS SAM. What is SAM? It is serverless application model. This is AWS framework to work with serverless, to prepare, deploy, control, test and generally manage Lambda functions and all resources, which almost all resources, which you can use with serverless. Of course, you have another framework, which is more, let's say, vendor agnostic, which is serverless IO. In this case, we use AWS. That's why SAM. One more information about SAM. Serverless application model is nothing else than just kind of element of CloudFormation. Generally speaking, CloudFormation, in fact, under the hood, when you execute the SAM template, it is translated to CloudFormation, to the classic CloudFormation. And what is CloudFormation? Obviously, CloudFormation here is the infrastructure as code approach, where we create our infrastructure in a described and declarative way. Obviously, we can use also the Terraform or CDK, but in this case, Terraform is third party, and I not use a CDK, even if this is very close to developers, because you can just programmatically work with the infrastructure. Here, I differentiate the infrastructure from the code of application. And that's why I'm using CloudFormation, right? So here for CloudFormation, I use a very specific approach. Normally, when you work with CloudFormation, you just create the stack, update the stack, delete the stack. Simple. But this is not CI/CD way, or not fully CI/CD way. I'm using something what is called change set, and change set has two elements. The first element is to create change set. In other words, this is CI part. I create the artifact, which can be used for me to be used in pull request. It can be used to create a self-documenting approach to the infrastructure, to the release change set, whatever, right? And then when it is accepted, I use the operation called execute change set, and the change set is executed. You will see it how it look in the pipeline itself. On the end, we use AWS CloudPipeline, and now I can say that I really don't like CodePipeline. I believe and I know this is a very powerful tool, but especially when you work with AWS, when you work with auto-scaling groups, where you work with ECS, so the containerized service from AWS or Lambda functions, it is amazingly powerful. And the deployment which you can do everything. You can do Canary, you can do rolling, you can do blue-green. You have predefined templates for it. But the, let's say, user experience of work with CodePipeline is quite poor, to be kind. Okay, and CodePipeline contains a few components, right? We have first code commit, and this is just the code repository. This is the version control tool. Simple like that, like a Git, right? Then we have code artifact, which is reasonably new. It has like 2 years at this moment. This is something what we really missed, right? So very often we use JFrog Artifactory or other tools, or Git or Docker Hub for Docker containers, or ECR or S3 to store our code there. Right now we have code artifact, and we can normally properly work with .NET packages, Python packages, Java packages, and JavaScript packages, right? So this is very, very, very nice addition. We have code build, which is generally the part for CI, for every single aspect of CI, testing, controlling, scanning, and creating and storing artifacts. And very often, not necessarily wrongly, but it is also used for deployments. For example, when you have Terraform, probably you will use code build to deploy your stack, not code deploy. Right? Code deploy, which I mentioned, is the tool for CD, for deployment. Very powerful, but quite tricky to use. But I really encourage you to go through it and try if you are interested in CI/CD provided by AWS. All of this is closed in something what is called pipeline. This is like an orchestrator. In this pipeline, we take blocks from code build, from code deploy, from code commit, and create the structure, what and how we will deploy. Right? We have something called Code Guru. This is additional service, very nice one, quite young, and Code Guru has two functionalities. And the one which we can use in scope of CI/CD is pull requests. Code Guru allows you to add, let's say, mechanical reviewer of your code. The power of it is that AWS use the full power of machine learning and full knowledge from all repositories in AWS to give you the proper review. Right? So you can use this as an additional reviewer here. All of those elements can be encapsulated, let's say, with or inside CodeStar. And CodeStar is a service which will create a code pipeline, code build, code deploy, everything, a lot of roles, a lot of other resources. Honestly speaking, from my personal experience, I used it once, I was scared like hell, and I deleted everything because I really didn't know what CodeStar created. I spent like a 20 minutes to look on different services to understand what happened. Thank you, no. So I'm using CodePipeline. Right, so do you remember what we will create? Very simple thing, right? So in order to create it, this simple application, one Lambda function, one API, we will use, of course, Lambda function, of course, API, of course, SAM CloudFormation template, the pipeline CloudFormation template, chain sets, event branch, because this is needed. Unfortunately, in CodePipeline, there is no direct connectivity between code stored with code commit and execution of the pipeline. You need to have some trigger. This trigger is realized here by event bridge in order to trigger your pipeline. We will use code commit, code build, couple of them, code deploy, right? Why not? SNS topic, in order because we build code, we build continuous delivery. That therefore I need to inform someone, in this case me, in this case myself, that something waits for my approval. Obviously, everything in AWS needs IAM roles. And of course, S3 buckets, where we will store, or not we, where CodePipeline will store like a temporary artifacts. You will see it in the second. So for one single Lambda and one single API, if you think that's enough of icons, no, it's not. Right? So what is built? This is the repository where you can look at and you can copy this repository and play with this by yourself. And to this in this repository, we will create this with CloudFormation. Here, we build CodePipeline, which will be connected to existing code commit, and through the event, which will be triggered through event bridge, we will have the code build for testing, code build for building the artifact, code deploy with the notification, which will execute SAM template in order to create or update API and Lambda function. Right? And the most interesting part here is this code deploy, because it contains 3 elements. it creates a change set here. There is manual approval. And on the end, I executing the change set. Why I did it this way? I told you before that create change set should be the CI part. Yes, that's true. But here it's more like for teaching process or showing process, it's easier to understand the construction of it. So we can go and jump to the console. So this is my AWS. I hope it is visible for you. And let's see first how the CodePipeline looks on the AWS. So CodePipeline has here the specific category, and this is our pipeline construction. So we have the first block, the first element, which is pull source, and pull source, of course, is pulling source from, in this case, code commit. It can be GitHub, it can be Bitbucket, and this is obligatory step. You need to have it always. Then we have another stage, which is test and code coverage, which when we are executing tests. After that, we have third stage when I'm using again code build to create the artifact. And after that, we have one big stage of our deployment of Lambda, which is called deploy, and it contains 3 elements. It creates change set. After the successful creation, it sends the message to my email, and then when it is approved, it executes the change set and provides the change into the infrastructure. So let's jump now to the source. And let's talk a little bit what we have inside, how we build it. So first of all, it's very simple repository. And here the important element is to understand how we build the structure of our repository. Because we have multiple approaches. We have monorepo, we have repo per function or functionality or microservice, depends, right? How to build it for serverless? There is a long-lasting discussion, unended discussion, right? But in fact, as usual, and as always, the best answer here is, especially from DevOps, it depends. Generally, the best approach will be when we have our template for serverless, our repository should contain exactly what is in this template. So if our template will deploy only one function, our repository contains only one function, period. If our template contains more functions, this repository should contain more functions. How to decide how many functions it should contain? Please remember, we do microservices, and this is serverless is kind of microservice, right? We do this in order to decouple our application. Decouple application doesn't just mean Docker container somewhere or Lambda function somewhere. It means decouple the application from code to working entity in environment. It means we need to decouple the code as well. If we have monorepo, we still have monolith. Right? I can talk a lot about this, but not today. That's why, in my case, in my template, we can find a couple of elements. First of all, as you see, it's quite simple, quite standard CloudFormation template. On the beginning, I'm decided to create a special log group in CloudWatch. We don't need to talk about this. Here I have additional layer for my Lambda function with something what is called power tools. This Power Tools allows me to build proper observability. This is different talk. Here I have a definition for my API. This is not the structure of the API, not the endpoints. It's the definition of the service in AWS, where I say what kind of stage I want to have, if I want to have tracing enabled, what kind of logging level I want to have from my API, what is the log format for my API, right? For every single endpoint. Below, I have my Lambda function definition. And here you can see how with SAM template, we can achieve the approach to GitOps, right? Where we keep code together with the infrastructure, we deploy it together, etc., etc. So GitOps works not only for Kubernetes, it really works for serverless as well. So what we have here, first we say that we want serverless function, right? And we have a couple of properties. One of them is the handler. What is handler? In case of serverless on AWS, handler is the name of, we can say this way, is the simple function, is the name of the file, and then the name of the main function, which will be executed when I trigger this Lambda function, right? Where is the code of the function, Lambda function directory? Where we go a little bit higher, you can see here there is, there is a Lambda function directory. Come on. Then we say a runtime for our function is Python 3.8. We added some IAM policies in order to have to allow this Lambda to access other services or other resources. We want to publish alias of our Lambda function. This means that we can version our Lambdas. Therefore, we can come back. We can revert if something is wrong, right? This is description. It's self-explanatory. How much memory I'm giving to my Lambda function. What is the timeout? Maximum timeout is 15 minutes. Please remember this when you create your application, your workload. And you are paying for the execution time and the memory. So these two elements here, memory size and timeout, you can treat as a your billing indicators. Okay? If I have tracing active, yes, I have. This is for X-ray. This is for observability. What kind of layers I'm adding to my functionality. And now a little bit of explanation here for layers. This is concept which is very important to understand and very good to use. What we can have with layers. Imagine your Python, I'm not the developer, so I'm sorry for my wording. Imagine your Python application, Python script. Generally, most of you, I believe, use import something from something, import something, right? We are importing some information, some part of the functionality from the external sources. And we can use some specific external source in order to serve this functionality to multiple scripts. And also we can update this functionality without impacting the script, and then we can update the script if we wish. The same is here. This layer, you can treat it somehow, let's say in quotes, like a imported resource, important part of the code from somewhere else. In this case, I'm importing Power Tools for observability, and I'm importing Lambda Insights for a more detailed information about the function execution in AWS. After that, I can define some environmental variables, like here. Here I have 3. Those 3 are for my Power Tools, right? Log level Power Tool, service name, Power Tool, metric space, namespace. And on the end, I have event. And this is the clue which allows me to say that this is GitOps. Here, with the definition of my Lambda function, of my let's say, business functionality. I'm defining how this functionality should behave and how it should react on some actions, events, etc., right? That's why I say here that this Lambda function is connected through the just /endpoint to my API. Right? This is the API which I defined here. And this is all 70 lines with added observability, and this will deploy Lambda function with API. Now, in order to use this in my CI/CD, I need to deploy also the CI/CD itself. But before we go there, I just want to show you how the Lambda function looks like. It's very simple. Very simple Lambda function. Here we have this handler I mentioned, right? The function called handler, and I execute very simple additional function to show you how unit test can be implemented in in CodePipeline. So this is very dumb, very simple, and I mean it very simple Lambda function, and probably even wrongly written, but it doesn't matter at this moment. So infrastructure for the CodePipeline itself. I have two parameters. As you see, it is also CloudFormation. I have two parameters. One is for my email. Second is for my source, where the code is. I need to create a bucket, which will be a temporary bucket for my pipeline. Let's see where it will be used. It will be used for every single transition state. So get source will do kind of git clone, right? And keep this artifact for this stage. This stage will do something and create the artifact for this stage. This stage will do something and create this artifact for this stage. Right? And this is temporary artifact. These are not the artifacts which we use to deploy to work with. This is internal for CI/CD, for the CodePipeline. We don't care about that. Okay, then I create the notification topic, SNS. I have a lot of policies which I need here. So it's a lot of them. And then I have the definition of my, of my pipeline, Lambda pipeline, which is the type AWS CloudFormation pipeline. And here, what I'm designing here in this part of the code is exactly this. So I'm saying what kind of stages I have and what will happen in the stages. So I have pull source, which is here, right? For the input artifacts, I don't have anything, obviously, because there is no internal input artifact. So input and output artifacts here in this are here and here are this internal, what I said to you about that. So I create this using code commit as a provider. I can use GitHub, for example, and I'm saying, where is it, right? This is the repository for the branch master. Then I have test coverage, test and code coverage, which is called build. And here I say where the definition of it is. This definition is exactly what is inside this block. Okay. I have another stage, which is again code build for building the Lambda function. This is this step here. And on the end, I have deployment for Lambda, which contains 3 steps. One is create change set, category is deploy, action create a change set, right? Then I have manual approval. And on the end, I have execute the change set, which is again deploy here, CloudFormation, and change set execute the action. And how this description inside like in this block looks like, it's quite similar to other CI/CD tools. So I'm defining here from where I'm taking the artifact and what is the artifact type, what is the environment on which I will build my artifact. So in this case, I'm taking Linux container, a general, defined as a general by AWS, and this is using Amazon Linux, right? Simple. And here I have very simple information what will happen, right? So now I want to show you one more thing. In order to do that, I will use my other terminal, not this one, because as usual I talk too much. So this was the terminal, and what we will do here in the code of template, we will change the version of Power Tools. So I can change the code itself. I can change the configuration of Lambda function here with the template. And also I can change the configuration of the CI/CD pipeline here in the IIC, right? So I can do everything here in the single repository. So in order to do that, I need to use CLI command for taking the last version of this Power Tools layer. As you can see here, I used here 1.25.1. Let's check what is the last version of it. It is 1.25.5, right? So I'm changing here to 5. Save. Okay, yeah. Okay, to do. Pushing the code to the repository. Let's see what we have here in the code. If this was updated or not. Here we can see the commits. Yes, there is new commit. And now what happened? When I committed something to master branch, it triggers the event. And this event checked this specific repository and this specific branch. And if something was changed here, it executed the pipeline, hopefully, yes, in progress. So we can see it. Code was collected. Now the Lambda test is in progress. We can see details of it. Generally, like always, like in every single tool, you can see how it goes, right? What is important here to understand this is this phase details about the every single stage. We have multiple like phases here, and here we can analyze where we have bottlenecks. And we have also something very nice, what is reporting. It was added like 2 years ago. It was missed before. So we can see, for example, here I have a code coverage summary. I can even see what is the code coverage for specific files. I'm using classic, tool set from Python to do that. And here I have my unit tests, right? Obviously, on both of these kind of reports, I can fail my pipeline. Okay, so test is completed. Now build started. Let's see if this will be able to finish in 2 minutes. Of course, here I can also click and see the progress. Even I can keep it on the end. And here you'll see the most important comment. Here I'm building the artifact, right? So I'm using AWS CloudFormation from CLI. I create a package using my template file, which you saw template YAML. I store this in the S3 bucket. And in this case, this is my artifact bucket. And I store it as a output template YAML. And this later is pushed to the repository, to the S3 really. Right now, I'm creating the change set. We can even see this on the CloudFormation console. So when we go to stacks, come on, be faster. Yeah, it waits for my approval. Come on, be quick. Interesting. You need to believe me in my words. So it created the change set. This change set means really what will change in the stack. Then I can review it, do some comments, approve, and after approval, it will execute the. Interesting what happened here. Why it cannot show the stacks. Probably something. Oh, yes, we have it. So as you can see, there is an additional stack which was created for the Power Tools itself. But here for Lambda demo, probably I will be able to see it now. Here, this change set is created, and I can see this change set here. And this is what happened in this change set. This is my change set really for the documentation, right? Okay, so we were able to deploy our function with only with the AWS stack. Thank you very much for your attention. And if you want to stay with contact with me, please, this is my contact places. Thank you very much. I hope you enjoyed the session, and I hope you will enjoy the rest of the conference.